So this video includes a brief description of the concept behind the operation of a laser. So a laser light beam has the following properties. So first, the light is coherent with all the waves exactly in phase with each other. And this means that we can get an interference pattern not only by placing two slits in front of a laser beam, but also by using two beams from two different lasers, okay? And the second property is that the light of a laser is very nearly monochromatic, which means it has a single wavelength, okay? Also, a laser beam hardly diverges. So, for example, if a laser beam is sent from the Earth to a mirror on the Moon, the beam reflected back can be detected, okay, without much diversion. But in a normal light beam, this is not possible because it would have diverged and spread out a lot during this trip. And the fourth property is that a laser beam is extremely intense, okay? And the term laser, it stands for light amplification by stimulated emission of radiation. And the key for laser is the existence in many atoms of one or more excited energy levels that has lifetimes of 10 to the minus 3 seconds or more instead of the usual 10 to the minus 8 seconds. And this relatively long lifetime state here is known as a metastable state. And this is an ordinary excited state. So as you can see, this state here, it decays faster to the lower level than the metastable state, which takes longer to decay to the ground state. So let's suppose we have two energy levels, E0 and E1. Then the transition between these two levels in an atom that involves electromagnetic radiation can be of three kinds. So the first kind of transition is that if the atom is initially at the lower level E0, it can be excited to E1 by absorbing a photon of energy h mu, which is equal to E1 minus E0, okay? And this is known as induced absorption. And if the atom is initially in the upper state E1, it can drop to E0 by emitting a photon of energy h mu, and this is known as spontaneous emission. And this is the third kind of a possible transition, and it was pointed out by Einstein in 1917, and it is the key to the operation of a laser. And it is known as induced emission. So here, an incident photon of energy h mu causes a transition from E1 to E0, and in this case, the radiated light waves are exactly in phase with the incident light waves, and this results in an enhanced beam of coherent light. So this is the laser, okay? So Einstein showed that induced emission has the same probability as induced absorption. And this means that if a photon of energy h mu is incident on an atom that is initially in the upper state E1, the incident photon has the same probability of causing the emission of another photon of energy h mu, like in this case here, as the probability of this incident photon being absorbed if the atom is initially in the lower state E0, like here, causing an induced absorption. So the likelihood of this transition is the same as this transition, okay? So this is here the simplest kind of laser, and it is a three-level laser. So this kind of laser uses an assembly of atoms or molecules that has a metastable state, okay? And also it has an excited state that is higher than the metastable state and that decays into the metastable state. So from E0 to E2, we have induced absorption, like this one here. And from E1 to E0, like here, we have induced emission, okay? So to get laser from these three-level atoms, the key is to have more atoms in the assembly in the metastable state, like here. So more atoms in this state than atoms in the ground state. So that if we shine a light of frequency mu on these collection of atoms, there will be more induced emissions from the atoms in the metastable states than induced absorptions by atoms in the ground states. And this results in an amplification of the original incident light. So normally for an assembly of atoms, most atoms are in the ground state, but if the assembly has the majority of atoms in a state above the ground state, then the assembly is known to exhibit population inversion. So the term population inversion is used to describe this situation where the majority of atoms in the assembly are in the metastable state, okay? So there are many ways to produce population inversion, and one of those ways is optical pumping, where an external light source is used that has some of its photons with the right frequency to raise atoms in the ground state E0 to an excited state E2 that will spontaneously here decays to the metastable state E1. So these are the levels in the atom used in this kind of laser. So this transition from E0 to E2 is induced absorption. And E2 here is an ordinary excited state with a short lifetime of about 10 to the minus 8 seconds. So after the atom is excited to E2, it will spontaneously decay to E1, where E1 is the metastable state. So the next step is that the atom is now in the metastable state E1, which has a longer lifetime than the ordinary excited state E2. So each dot here is an atom. So first, the atoms are pumped from E0 to E2, then they spontaneously decay to E1. Then now we have this situation which represents an assembly of atoms that exhibit population inversion. So here the majority of the atoms are in the metastable state. So now when a light of photons of energy h mu is incident on this assembly of atoms, there will be induced emissions from the metastable state to the ground state. And because the majority of the atoms in the assembly were in the metastable state, then when this light is incident, there will be more induced emissions from the atoms in the metastable states than induced absorptions by atoms in the ground state. And the radiated light waves by induced emission are exactly in phase with the incident light. And this results in an enhanced beam of coherent light, and this is the laser. And the reason 3 levels are needed is because let's suppose we have only 2 levels, E0 and E1, so the ground state and the metastable state. Then pumping will induce downward transitions from E1 to E0 and an equal amount of upward transitions, okay? This results in half of the atoms to be in each state. And so the rate of induced emissions will be equal to the rate of induced absorptions, okay? So the assembly cannot have more than half of its atoms in the metastable state, in this case of a 2-level system, okay? And this means that laser amplification will not occur. But in the case of a 3-level laser, the induced absorptions are to a higher energy level than the metastable state, where induced emission here takes place. So this kind of levels will prevent the pumping from depopulating the metastable state, and this results in this population inversion, which means there will be more induced emissions than induced absorptions, which will result in this laser amplification. So thank you for watching. Please don't forget to like and subscribe, and see you in the next video.